All right, welcome back again. Now it is Friday. We're continuing section 2.6. The second part of it won't be as long as yesterday. I just wanted to give you as much as I could so you can get started. So let's just work on the fine little details, and we'll start by reviewing one of the questions right out of the homework. So I'm gonna switch my camera over here. And this one right here, once again, this seems to give people some trouble because I know it's a little funny here. You got something going all over the place. So let's check out number 9. And we'll also tell you some tricks today about how to find horizontal asymptotes. We'll start with this first question. Here we go. As we approach -3. Okay, so here's my graph. You can also see it in your book if you happen to have the book in front of you. So it says, let's get close to -3. Okay, there's -3. And f of x just means y. Where's the graph headed? And I got a bunch of pencil marks here. Okay, so let's find -3. Now, which side of the -3 are you looking at? See a little minus? Means go a little negative of it. Go a little bit to the left of it. A little bit to the negative. So as I look at -3, but a little more negative than it, where's the graph headed? Get really close. Where do you see it? In fact, you're kind of squeezed right in here, aren't you? Just a little this side, and you're like, oh, it's going down. Well, what's down below? What's the deepest you can get? Negative infinity, the farthest down you can go. It's going down to negative infinity. Well, number 10, if you do -3, but a little bit on the other side, a little more than -3. So I'm just looking right in here. There's -3. Okay, but a little bit bigger than -3. I'm trying to do it so you can see the number. Where's the graph? Where are the kids running? They're running off the top into the sky. They're headed to positive infinity. Okay, let's look at the next question. Okay, so maybe you can think about these two. Here's 1. Where's the graph headed? Some are headed up, some are headed down. When they're a little smaller than 1 or a little bigger than 1, think about where they're at. Come up with your answer. Just a little bit. Let's see it better. Okay, as we approach 1, but we're a little bit smaller. Here's 1. But a little bit smaller, the graph is down here. Okay, so just a little bit smaller, you're down below. So we're at negative infinity. And we're at 1, but a little bit more. So 1, but a little bit more. I guess some glare there. You're at positive infinity. So you're going up. Okay, next question. What about when the children run to negative infinity? Now, which negative infinity? Not up or below. X, right? X. When the children run to negative infinity, so they're running off the paper. They're headed to negative infinity. Negative infinity is way out here, isn't it? So when the children run the negative infinity, what's the height? Good. It's not way up high. It's not way down low. They're getting, looks like they're getting close. Oh, horizontal asymptote. They're getting close to the y-axis, aren't they? They're getting close to 0. So see this graph? When they run this way, they're not going into the sky. They're not digging a hole in the ground. They're just going straight across. They're headed to 0. And what about the kids running the other way to positive infinity? They're going like this. They're also headed out here to infinity, but they're getting lower and lower and lower. But once again, they're getting close to 0. There's this horizontal asymptote at 0. So they're headed to 0. That's how it works. Okay, so as you get close to a number, you generally go up or down. As you head to infinity, you're probably headed to 0. But sometimes you actually head to like a number. And let's learn a few more tricks. I'm going to also tell you, why do I want to know about this? So let me move this out of the way. But I made up a little problem here. Make this a little more interesting. Okay, let's say I want to open a lemonade stand. Okay, the classic lemonade stand. And I'm going to sell some lemonades. And I'm wondering, how much should I charge for lemonade? Well, I had to make the lemonade stand. So let's say it cost me $100 to build the lemonade stand. And I had to buy things like a juicer and a pitcher, things like that to put the, to run the stand and signs and stuff, and a chair to sit on, and maybe a cooler. So I spent $100. let's say to make each lemonade, it costs me $1 because I need sugar and water and ice cubes and all this stuff. So it cost me $100 to build the stand and $1 to make each lemonade. So what should I charge for a lemonade? Should I charge 10 cents? Well, if I charge 10 cents, I'm going to lose money, right? If I charge $1, I'm not going to make any money, am I? I need to charge more than $1. So let's find out what is my total cost per lemonade I make. So I need to charge more than it costs me to make a lemonade. And don't just think, well, I need to charge more than $1. Well, that is true. But let's say if I made, oops, I need that paper. If I made, let's say just for example, let's say I spent $10 just total, right, on something to make 5 lemonades. Okay, say I spent a total of $10 to make 5 lemonades. Then it's costing me $2 divided by 5. It's costing me $2 per lemonade, just for example, right? Say I spent $10 to make 5 lemonades. That's $2 per lemonade. So I should charge more. But let's look at our question. Well, what is my total cost? So what I'm going to do is I'm going to make a little graph here. And I'm going to say this will be the amount of lemonades. And this is going to be my total cost. So, well, what if I made 1 lemonade? Okay, so let me make a little table here. Number of lemonades and my total cost. Okay, so if I made 1 lemonade, notice it's going to cost me $100 plus $1. I want the total, right? I spent $100 to build the stand. I make 1 lemonade and then I close up. That's not too smart. It would cost me $101. So like, here's 101. I'll put a dot right up here, right? So 1 lemonade, if I just build a stand, make 1 lemonade and then say, okay, I'm done for the day. It cost me $101 to make that 1 lemonade. Not too smart, right? If I made 2 lemonades, it would cost me $100 plus 2. But what's the price? I'm going to put price per lemonade, okay? Price per lemonade to make this more accurate. 100 plus 2 divided by 2. Okay, so I spent $102, but I made 2 lemonades. So that's 102 over 2, which is $51. Okay, so I want the price per lemonade. So 51, I didn't leave enough room, darn it. Okay, there's $51. So now at 2 lemonades, we're 50. Okay, I'll make a little more room. If I make 3 lemonades, it costs me 100 plus 3 divided by 3. Man, I got to get a calculator out for that one. I spent $103 over 3 lemonades, $34 and some money. Okay, so about 34. Notice it's coming down, isn't it? This is what companies do. The more they make, the less it costs them for each item. If I make 4 lemonades, it costs me $100 plus $4 to make it. Divide the price among 4. The price to make each lemonade overall, the overall cost, I spent $104 over 4 lemonades. It cost me $26, right? So as I make more, the price comes down. Let's jump out to 10. If I made 10 lemonades, I spend 100 plus $10 divided by 10, which is 110 over 10. Now the price is only $11 per lemonade, which is down here. Look what's happening to the graph. It's getting lower and lower, isn't it? Will it ever get to 0? Can my price ever be $0 per lemonade? I think I got the rule. You take $100, you count up the amount of lemonades, and you divide by how many lemonades. This is my rule, and this is the why, isn't it? So this is my rule. In fact, as I put bigger and bigger numbers in, let's say I sell 1,000 lemonades, okay? Can the price ever get to 0? Is it ever going to cost me nothing to make a lemonade? Well, $100 for the stand, $1,000 to make 1,000 lemonades because it's cost me $1 to buy the lemons and sugar, and, put in each little cup, divided by 1,000 lemonades. So if it cost me $1,000 plus $100 for the stand divided by 1,000, that gives me 100 plus 1,000. Whoops. Okay, cost me $1,100 divided by 100 lemonades. I'm probably getting the 1 to work. That's a, oops, I've left the 0 off. Let me try it again. $1,100 divided by 1,000 lemonades, $1.10. Okay, 1.1. So when I get up to way out here to 1,000, the price is getting lower and lower and lower. It says $1.10, doesn't it? In fact, guess what I'm getting close to? $1. This price is getting closer and closer to $1, isn't it? But it never gets less than $1 because every lemonade costs me $1. So this is the horizontal asymptote. At $1, right, just like this, we're getting a horizontal asymptote of y equals 1. We're getting closer and closer to making it just cost me $1. Eventually, after I sell millions of lemonades, I'm so rich. Who even cares about the $100 anymore? It's like Bill Gates or something, or Jeff Bezos. After he's sold millions of stuff, he doesn't even care about that $100 anymore. He just throws them around. And also look at the graph here. Well, it's never going to be negative. What is it going towards over here? It's going up, up, up. Can it ever touch 0? Is there a vertical asymptote at x is 0? Well, if you look at the rule I made, see my rule? X can't be 0, can it? It doesn't make sense to have 0 lemonades because you can't divide by 0. So I know, in fact, it doesn't even make sense to put in a half of a lemonade, right? Maybe I sold half a lemonade, but yeah. So if we could put in decimal amounts of lemonades, we get like this because you can't divide by 0. So if you make none, you just lost all your money. And of course, what should I charge for lemonade? Well, the more I make, the less I can charge, as long as I charge more than $1. But if I only make like 2 lemonades, I better charge a lot of money. Or if I only make 3, I better charge more than $34. But if I make enough, I can charge people. Maybe I could charge them only $1.50, right? I'll charge people $1.50. Then I can make money as long as I sell lots and lots of lemonades. And that's how places like In-N-Out Burger can keep their prices down. They sell so many, they can keep the price low and still make a profit. But if they don't sell that many, it's all exclusive, they have to charge more. Okay, so that's pretty cool. Let's talk about some shortcuts of how to find these asymptotes. Okay, so we're going to talk a little bit about how to get those horizontal and vertical asymptotes and stuff. Okay, so I'm going to let you in a little shortcut some people discovered. Okay, let me switch over to my stuff here. And we'll go to here, and we'll go here, and I'll go here for a second. Okay, and I'm going to stop share. I just want to make sure this pops up here correctly. Okay. Okay, so here's like a graph. Of course, we're pretty good at the vertical asymptotes, -2, you know, but you know, we can't have -2 because that's the band number from the bottom. But what is this graph getting close to? As I follow it, it's getting close to, it's getting close to 1, isn't it? Some graphs get close to 0, some get close to 1. How do I know this? Okay, so here's a nice little shortcut. Okay, I'll try to make this simple. Shortcuts to find the horizontal asymptote. Okay, I'll let you know. I'm going to split this into, there's 3 possibilities. Sometimes the horizontal asymptote heads to 0. Okay, here's a piece of graph paper, and it's headed to y is 0. You know when this happens? This happens whenever the bottom has more x than the top. For example, 1 over x. You see more x down here? Heads to 0. Like some graph goes wee like that, okay? Here's another example. How about 4x over x squared plus 1? Check out the x's. X, but x squared. Where are there more? Where are there more x's? Don't care about, who cares about the numbers? More here, right? Okay, so when you have more x degree, more x power, right, on bottom. Okay, here's another one. What if I put 3x to the 4th plus 1,000, but the bottom is like 2x to the 5 plus something. Once again, you go, who's winning the power battle here? Is it 4 or 5? You're like, I win. I got more power. We're going to head to 0. So if the bottom wins, bottom is bigger power, okay, the graph heads to 0. Okay, so you'll see that the bottom's a bigger power, it heads to 0, because if you ever have a bigger number on the bottom, you know, if you have 5 over a big number, when the bottom's a bigger number, what does the answer head towards? Well, that's in scientific, that doesn't help me, but a really, really tiny number, right? Heads to 0. Okay, next possibility. Sometimes the graph heads to a number. Sometimes it heads to like y is 5, right? So if the bottom's bigger, heads to 0. When does it head to a number like that? I'll write one, watch this. 5x squared over x squared, I don't know, plus 1. This is when you've got a tie. If it's the same, then all you're going to do is you're going to look at the main part right here. You're not going to look at the rest of the insignificant money, right? Just the big money. Okay. If you put in a big number like, I don't know, let's try 100. And when you go 5 times 100 squared, you get something big, divided by 100 squared plus 1. Oops, I better use parentheses there. Just make sure that's all in the bottom. Then my answer is, what's that close to? That's close to 5, isn't it? That's close to 5. Because if you do like 5 times 1,000,000 over 1,000,000 plus 1, who cares about the dollar? If I give you $1 million and squared it times 5 divided by 1,000,000 squared plus 1, this dollar is insignificant. So if you see a tie, just look at the numbers in front. If you're like, I don't get it. Okay, here's another one. What if I put y equals 8 x to the 3rd plus, and there's a bunch of other stuff, over 2 x to the 3rd plus a bunch of other stuff. Just look at this. Oh, we got a tie. What's like 8 infinity over 2 infinity? 8 infinity over 2 infinity is going to be about, what's our number going to be? That's going to be 4. This guy here is 5. This guy's 4. Here's one last one. Okay. Y equals negative 6 x to the 4th plus blah, 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 blah. A lot of stuff over 2 x to the 4th plus a bunch of stuff. All you got to do is check out the main guy, the main power, and go, oh, we got a tie. We got a tie. And if it's a tie, we'll just say this guy heads to negative 6 over 2, negative 3. So that's a neat little shortcut. So if the bottom's bigger, go to 0. If you got a tie, check out the numbers. What's the last possibility? Oh, what if the top is bigger? So what if we have a big thing on top, like x to the 4 plus, it doesn't matter, but the bottom's only like 3x squared plus 1. If you're like top bigger, right? That's bigger than the bottom. Well, guess what? There is none. Okay, no asymptote, because what happens if you put in a big number, like infinity to the 4th, plus some extra stuff over infinity squared? Isn't infinity to the 4th over infinity squared pretty big? When you plug it in calculator, you'll get giant number, right? You'll get a giant number. What happens is the graph just goes, the actual graph itself just goes whoop, up into the sky. Okay, so there is none. The bottom's outpowering the top. So as you put as you make a table and put bigger and bigger and bigger numbers, the answers get bigger and bigger and bigger. So it never heads towards a number. If I put in 1, it's small, but if I put in 100, the top's like 100 times 100 times 100 times 100 over only 3 times 100 squared. Top's out of control. It's just going up to infinity, so there is none. So there's a neat little summary of how to find the horizontal asymptote. Feel free to take a picture. If you need it paused, you can pause. Okay, I'm gonna show you, watch out for one trick question. Okay, here's a graph, x plus 3, x plus 2. Notice -2, it's an error, right? And what is it headed to? Horizontal is 1, because look, it's a tie. 1 over 1 is 1. If I put a 2 here, it's headed to 2. It's a tie, 2x over x. If I put a 4, it's headed to 4. Okay, let's just take that back. And I can change this other number, it doesn't matter. X plus 4, x plus 5, x plus 6. Oops, I can't see the whole graph. But watch this, I'm gonna do something really weird here. Okay, x plus 3. Let's change the bottom. Okay, wait for it. What if I change the top? Let's change the top. What if I change the top to, okay, x plus 1, x plus 2. Wait a minute, what happened? Whoa. Where's my graph? What happened to the whole graph? Check it out. They're the same, aren't they? They canceled out. Anything divided by itself is 1. Oh, okay, well, that's weird. But wait a minute. Isn't -2 a forbidden number? Look what happens when I trace this. Okay, see the dot, see the dot, see the dot? What happens when I get the -2? Undefined, but look, there's a hole. You see it's hollow? Here it's solid, but there's a hole. Okay, let me put something else up here. Let's put x plus 5. Okay, put something there. Okay, here's a graph. Oh, that's a weird one, right? Why is it curving weird like that? What if you foiled the top? Isn't the top x squared? X squared is bigger than x. No asymptote. Okay, yeah, there's no asymptote there. But what if I change the bottom to x plus 2? And you're like, wait, the graph's gone. What happened to it? A straight line. Okay, -2 is forbidden, but look what happens when I drag this to -2. Where's -2? Undefined. It's a hole. Okay, I'm gonna show you this in the book. It's a little weird. You lose the asymptote because it got canceled off. Okay, let me leave this because I know that's kind of really bizarre. Oops, let me get this to here, to the camera. Okay, a little example. Where did you go? Okay, right here explains the idea of the hole. Okay, so say you're seeing a problem and you're like, I'm going to graph this problem. Paper right here. And you see this problem right here. You're like, okay, oh, can't be 3, right? Don't want no 3s. And the first thing I'm just thinking, I'm just working along, doing my work. I'm like, oh, x can't be 3. We're going to put a vertical asymptote, right? But whoa. Whoa, hold on there, partner. Can you factor the top? Oh, you didn't do that to me, did you? Look at this. X squared plus 9 factors. Plus 3 minus 3. And the bottom's minus 3. And remember, we were going to put a vertical asymptote there. But if you factored, it canceled. You just canceled the vertical asymptote. So now this equation is just becomes y equals x plus 3. It's just a boring straight line now, isn't it? But we're still not allowed to put 3 in. So what happens? It just looks like the line x plus 3. But you know, you got your graph and you just draw this line. But where 3 is, you got to remember it's a forbidden number. It's just merely a hole in the graph. I don't want us to panic too much about that because I'm not there. It's just once in a while you're like, why is there not a vertical asymptote? Like, oh, because we canceled it. And so if it got canceled, cancel culture here, the vertical asymptote got wiped out. And the only thing left to him is he fell in the hole. There's just a band number. And last thing, let's see if we can put this all together. Let's go advanced style. Let's do a double vertical asymptote. So I'm going to make up a problem like this. Oops, my pen don't write. X plus 5 and maybe like x minus 3. And you're like, how do you graph one of these guys with two vertical asymptotes? Okay, so here's my strategy. Graph paper. Okay, so what do you know how to do so far? Here's your ultimate challenge. So here's your question. Let's find the vertical asymptotes. And I might say, okay, everyone you tell me, I'll give you a point. And you're like, well, you can't pick -5. So at x is 5. 1, 2, 3, 4, 5. We're going to go. Let's not deal with any weird holes, okay? Okay, x is 5. And then, 3. We got another one. X is 3. Or if you like to say x can't be, that's fine. I know what you mean. 1, 2, 3. Oh, I just messed this up, didn't I? Where's this guy? -5. Okay, hang on. Let's fix this. I don't want to go through all the editing. You can't believe how long it takes to edit that out. Okay, -5. X can't be -5. 1, 2, 3, 4, 5. This is where I want to be. Okay, that's at -5, the band number. And at 3. So we can't have one at 3. 1, 2, 3. We're going to do this whole thing like a pro. Boom, 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 boom. Okay, let's check out horizontal. Say, is there any horizontal asymptotes? You know, in other words, like this. And how do we do that again? Oh, plug in a big number. Or do you remember the shortcut? More x's on top or bottom? More on bottom. If it's bottom, it's at 0. And if you're like, I can't remember that, then that's fine. Just put in a big number like 100. If you're like, I don't like that trick about more here, more there, I'm just going to plug in 100. Okay, 2 times 105 times 97. Let's see what this is. 2 divided by parentheses 105 times 97. Let's just see what this is. And oh, it's a really tiny number, isn't it? Okay, it's a negative scientific notation. It's so small. It's about 0, isn't it? Okay, so it's about 0. Okay, yeah, because the bottom's bigger. So let's put that. Now remember, this is only off the edges of the paper. I'm not going to put in the middle part, okay? Not putting in the middle. Okay, factor close to 0. In fact, wait, is that bigger than 0 or less than 0? Is it positive or negative? It's positive. It's above 0, isn't it? So I'm actually going to steal that as a favorite point. It's a little above 0. There we go. Let's put in, let's have the children run. They run along the fence. We'll run up to infinity. Okay, let's try way over here. -5. Let's try something to this side. How about -6? Okay, let's try -6. Where are we at? 2 over -6, -6. That would be -6 plus 5, -1, and -9. So that's 2 over 9, which is 2 over 9. Okay, it's just a small number, right? And is that positive or negative? That's positive, isn't it? Yeah. So -6, that's pretty close to 0, isn't it? If you got 2 out of 9, that's a small number. If you want, try a bigger number. So 2 over -9. So, but it's a little bit above though. It's a little above 0. Okay, let's run along the fence. Along the fence, don't send the kids into the fence. Don't stop there with an arrow. Make sure you follow the fence, okay? Always follow the fence. What happens in the middle? Okay, there's 3 possibilities. What we're going to have to do is we're going to have to try close to 3 and close to -5. They both might be up, and we would make kind of like a parabola, or they might both be down. We can make a down parabola, or maybe one's some of each. So this is the tricky part. This is the advanced part. Try something close to 3 on this side, like 2. Plug in 2. And let's see what we get. 2 over 7 times -1. That's 2 over -7. Okay, which is something negative, right? something down here. Okay, but it's low, isn't it? Okay, now let's try something over here close to -5. How about -4? Plug it in and see what you get. Put in -4 and -4. Let me let you try that one yourself. 5 and -4. That's 1. -4 minus 3, -7. That's 2 and -7. I'm going to check that again. 1, -7. Okay, that is negative something, right? It's close to 0, but it's also negative. It's also a little on the negative side, right? So it's also a little below, isn't it? And then we'll just kind of go like this and connect them. If this guy was up, if he were up here, we would go whoop and kind of make kind of a cube shape. So in the book, you probably noticed a little bit of different things that happen. Let me try to find a graph in the book. So sometimes you get like one guy's low, one guy's high, and you kind of like go whoop. But sometimes they're both low, and you kind of like bring them both down. Where exactly it bends, I don't know. I'd have to sit there and plug in points all day. Okay, and let me put this up here on Desmos. There it is in Desmos. That looks like our graph. You can sort of see our little graph there, right? There it is. I could zoom in a little bit, but there's the 3, there's a -5, and there's that. It's kind of funny. It just touches that. Sometimes it crosses over the horizontal, and that's where we'll stop. So go ahead, try the work, do the best you can, look at the work. I'll be back Monday, I hope. That's the plan. And I'll see you guys. And thanks for watching. And I guess we can stop the video. Oops, I'll stop that there. So see you guys, and bye.